Hi, students. Dr. Madewell here. Today, for our mini lecture, we're going to talk about variability and just an introduction to variability. Why do we need variability? This slide should answer that, and this would be a great slide to add to your cheat sheet. When we've talked about central tendency tells us the center of our data point. It gives us the mean, median, and mode. However, it's not giving us the whole story. Now, variability. This is a new term. Variability describes how spread out the data is from the mean. There are several types of variability we're going to talk about for several weeks. We're going to talk about and calculate variance and standard deviation, and then also range. We want to be able to compare two data sets because what we're going to do in our homework this week, you're going to compare two different data sets that have different mean scores, but they have different variability. So it's possible to have two different data sets that have the exact same aspect of central tendency, but their variability differs. I want you to be learning that from the homework. Now, when we talk about range will be our new term. It's the difference between the highest and lowest possible scores. If we look at this distribution here, when we look at the range of scores, our highest score is right around 12, and our lowest score is 4. So we can determine our range of scores very simply. In Excel, you can just look and see, in Excel, you can order your column from lowest to highest, and you can know your lowest score to your highest possible score. Our range is really helpful because if we say that maybe we say we have two different groups of people. Our first group of people, we ask them to exercise and go work out, and we wanted to see how many cigarettes they were smoking per day. If another group of people, we gave them some kind of a medicine to help them diminish their interest in nicotine every day. Well, what we'd want to do is maybe compare who's smoking less. If we say our exercise group is smoking 15 cigarettes a day and or fewer a day, and our medication group is smoking 30 fewer a day, we need to know the range of possible scores. It's like 15 to 30. That seems like a lot fewer cigarettes that they're smoking by taking our medication. So we want to make sure to be good researchers that we put the minimum number and the max number. And that way we have our range of scores. Now, if we only talk about the range of scores, it can be misleading. We also need to include the aspect of central tendency, our mean, median, and mode, and other aspects of variability. Our next aspect of variability is called variance. And variance is super duper important. Our variance is going to be our averaged squared distance from the mean. And I want you to take some time to write the population and sample formula. So stop my video and write both of these carefully and cleanly on your cheat sheet and your notes for this week. And hit play when you're ready to get back to the video. When we look at our population and sample formulas, in our population formula, we're going to utilize Greek denotation. This is lowercase sigma squared. Lowercase sigma is going to give us I'm going to annotate. Our lowercase sigma here is going to tell us variance. Our variance, lowercase sigma squared, is the sum. Here's capital sigma, lowercase sigma, capital sigma. Lowercase sigma looks like a little circle with a hat. Capital sigma is the big sum sign. We're going to sum up our score minus the mean score squared divided by n, which is our population size. In criminal justice and sociology, oftentimes you might deal with population data. That means you might survey everyone in your prison, and that could be your prison population. However, in psychology, we often focus on samples. So this one would be the one we're going to primarily be doing in our homework, and probably on the midterm and the final, you'll be calculating this. When we look at our variance squared, or lowercase s squared, look at the formula is exactly the same. We're summing up the deviations from our score to the mean, squaring those, and dividing by, now we have n minus 1. These two differences we're going to talk about in our future video. But go ahead and add that to your cheat sheet, and we'll keep on moving forward. When we look at standard deviation, what we're going to do is just take the square root of our variance. So if we look, or if we, my annotation is not turning on. There we go. If we take our s squared equals the sum of x minus x bar, that's a very large minus, and squared divided by n minus 1, this is called our variance. That's from the previous slide. To get to the standard deviation, what we need to do is we're going to take the square root of this. Square root of variance gives us standard deviation. It's more interpretable than our variance, and it tells us how much our scores typically deviate from the mean. Very useful tool. When interpreting standard deviation, when we have low standard deviation, that means our scores are very close to the mean. Oftentimes, that means we have less variability. So what that tells us, when we have less variability, if we were to draw out our data might look like this. Less variability. If we have high standard deviation, then our spread of scores could look like this. In both places, we need to think carefully about our data, the questions we asked, and what our interpretations can mean. We're going to be quite limited. So we're going to be quite limited here. We're going to talk more about that, and I want you to make sure you're reading in your textbook. For this slide, we have a little summary comparison. When we talk about range, it tells us the total spread of scores. It tells us the most minimum and the most maximum score possible. It could be affected by outliers, so that is a limitation. It doesn't mean that we throw anything away just because it has a limitation. We just interpret it carefully. When we talk about, and I passed over interquartile range, please look over that in your book. But we went ahead and talked about variance and standard deviation. They're going to tell us our typical distance from the mean, and our standard deviation is the most commonly reported. Super duper important. Please go ahead and make sure that standard deviation is a big one on your cheat sheet and also on your notes for today or this week. Next, we're going to talk about frequency distributions, and we're going to talk about what happens if your data is not normal. So our next presentation, you're going to have the handout for this week. Go ahead and have that ready, and we'll draw on it together. Thank you so much for your time today. I hope you enjoyed this lecture, and it helped you put together the information in the chapter. See you for the next video. Bye-bye.